Hi again, it's Mrs. Warner, lesson 2 coming up on circles unit. And in between taping lesson 1 and lesson 2, I just heard that Cuomo announced we will not be going back to school. Very exciting, folks. You'll be watching me from now until the end of June. Real excited. Okay, so here we go, folks. We can do it. Homeschooling. Okay, so we have a bunch of different theorems today that we're going to do. Our first one is central angle theorem. And if you want it written out for you, just to save time in making these videos, so it's not like a 30-minute video that you're watching, you can print out the PDF with it filled out in there. But our first theorem is the central angle theorem. And the central, why won't this move? And the central angle theorem basically says that, oh, there we go. I'm making a mess on the PDF. It says that if an angle is a central angle, in this picture here, X is the central angle. It comes from the center. The central angle is equal to the measure of its intercepted arc, they call it. So this arc on the outside is 23. So guess what the angle in the center is? It's 23 degrees. How easy is this? The angle and the arc are equal to each other. Okay, so in this case here, we have this central angle is 162. So guess what? This arc is 162. They're the same thing. Let's try some more because we're crazy. Okay, so now we have this guy's 233. Oh, shoot, we're going to have to solve for x. So we go 5x minus 2, but remember they have to equal each other, equals 233. 5x is going to be 135, or in this case, x is going to equal 47. That was fun. Same idea in the next example. The 6x plus 1 has to equal 73. So 6x equals 72. And 6 goes into 72 12 times, folks. The central angle is equal to its intercepted arc. Angles in the center, central angle. Okay, let's move on. Let's next talk about the inscribed angle. Now, you can tell from the first couple examples, there's a little bit of a relationship going on. See this angle, this intercepted arc is 140, and the angle back here is 70. Makes me wonder. If this angle back here is 39, its arc out here is 78. Guess what? The angle is equal to half its measure of its intercepted arc. So this time, instead of it being equal, we're going to take half. And in case you want the full theorem written out, you can always print out the PDF of the notes. Okay, so here we go. Now, the angle is smaller than what the arc is. This angle's 33. So to get out here at this arc, I'm going to double it, 66. 33 times 2 is 66. Remember, the angle is half of its arc. Okay, so if the arc is 218, I'm going to take half of 218, and half of 218 is going to give me 109. So that means that angle, or inscribed angle, inscribed because it's touching the side, the circumference there, different than the central, which comes from the center. Okay, here we go. This angle 69 has to be half of 5x minus 2. Well, I don't want to take half of 5x minus 2, so I'm going to multiply the other side by 2. So that becomes 138 equals 5x minus 2, or 5x is going to equal 140, and in this case, it's going to be 28 when I divide by 5. Let's do another one. This arc out here is 86. So 3x plus 1 is going to equal half of 86. Because that has to be half of that. So now I'm going to take half of that. So 3x plus 1 is going to give me 43. And if I subtract 1, I get 3x equals 42. So x is going to be 14 for my answer. That was super fun. Okay, so now let's keep moving on. We got some more. We have something called Thales theorem. Oh boy. Thales theorem says that if an inscribed angle intercepts a semicircle, it's going to be a right angle. Oh, look at this. Here's the diameter of the circle. A diameter is 180 degrees. So it makes sense that back here, this angle is 90 because this arc out here is 180. That's crazy. Okay, so let's see what we have for this question here. Okay, it says find the measure of arc. That symbol above there means arc AB. The arc AB is here. It's 180 degrees because of this diameter. Half of a circle is 180 degrees. Remember, full circle, 360. Okay, now we're going to find angle C. Oh, 90, because it's a right angle, people, because Thales theorem says so. Thales was a famous mathematician. Okay, so now find the length of AB. Ooh, it tells me the radius is 12.5. So 12.5 times 2 is going to give me 25 because that's a diameter. That was a piece of cake. And then it tells me A to C is 7. Look what we have, folks. A nice squared plus b squared equals c squared. 7 squared plus x squared equals 25 squared. And guess what, folks? I know this is actually a triple. So x, if you solve it out, is going to be 24. It's a 7, 24, 25 right triangle, which is a Pythagorean triple, like a 3, 4, 5. Okay, and our last theorem for today is the inscribed quad. Now, in an inscribed quad, generally the opposite angles were equal to each other. But guess what? Once you put that quad inside a circle, the opposite angles are supplementary. They add up to 180. They're not the same. Okay, so let's figure this out. From the measure of arc FG is 97. And from G to H is 117. E to G to H, that arc is E to H to G is 164. Okay, so if this is 117 and that's 164, this has to be 47 over there. Did you see how I did that? I subtracted them because this whole arc minus this part has to give me that. Now they add up to 164. And then I know I have a whole circle. So if I can find that, I know this guy is 99 because the whole circle has to add up to 360. Okay, so now that gives me all my arcs, but it says find the measure of each angle. Okay, we can do it. We can do it. So to find the measure of angle E, which is right here, E is going to be half of these guys added together. Because it's an inscribed angle, I have to add the two arcs that it intercepts in this picture. So if I add up half of 117 and 97, this guy comes out to 107. Okay, now to find the angle G, I know they have to be supplementary to each other because in a quad that's inscribed in a circle, they have to be supplementary. So 180 minus the 107 gives me 73. So that means this angle is 73. That was fun. Okay, now let's find measure of angle H. Okay, so here's H. I'm going to trace it to its arcs. It's half of 99 plus 97. That's an inscribed angle again. So if I add the two arcs it intercepts out here, you trace its chords back to find its arcs. That angle there ends up being 98. Okay, so now that means that Angle H is 98, and guess what? To find measure of angle F, I go 180 minus 98. 180 minus 98 is 82. So much fun. Let's just look at these quick examples down here, see if we can figure them out. If this guy's 120, I know the measure of angle Y is opposite it. And remember, they're not equal to each other when it's inside a circle. They add up to 180. So Y has to be 60. And I know that Z has to add up to 180 with the 55. So that's going to end up being 125. Remember, the opposites equal 180 degrees. If I want to find A to D in this picture, remember this is a diameter, so that means this is a right angle back here. So I can use 5 squared plus 12 squared equals x squared, and if you know your triples, you know that x in this case is 13, but that's not really the answer. To find AD, that's just part of it. It's the diameter, so the diameter, half of it would be 6.5 for its radius. That was so fun. Okay, my phone is blowing up over here because of the school closure off to the side. It's like dinging away. Okay, so here we go. I know this guy is 40. This guy is 90 because see in this triangle here, this is going to a diameter. So that's got to be a 90-degree angle. That means the measure of angle 1 has to be 50. And number 2 is super easy. That's got to go to a right angle, so that's 90. And that concludes our exciting lesson to the week, folks. And I got to catch up on all my text messages about school being closed for the rest of the year. And there's my buddy next to me. Bye, guys. Hope you have a good day. And I guess I won't see you. I don't know when. Come to a Google Meet so I can see